Second question is, what resources did you use? Did you go and use condense your notes? Did you try to use the best cheat sheet ever? Did you use a review? Did you study off of lab work? Did you study off of Pearson? What did you do? Okay? What did you do to study? Whatever you guys, write it down. Write it down. Like I said, this is something that is you looking yourself in the mirror and keeping yourself accountable. That's why I'm not collecting it, so that you can be truthful on it. So, when you brought your exam to me, question 3, when you brought your exam to me, before I put a grade on it, before I scanned it, what grade did you think you were going to get? I'm sure that some of you guys thought, I got an A, you got an A. But I'm sure that some of you guys thought, I got an A, you got a C. Or you're like, oh, I probably got a C, and you got a B, or got an A, right? So some of you guys got that pat on the back, and some of you guys got slapped in the face, right? So what did you expect to receive as a grade, A, B, C, or D, right, versus what you actually got? What did you expect to get? And the last question is, now that you know what your grade is, how would you change the answer to question 1 and the answer to question 2 to better your grade in exam 2? Now, I do believe that you should ask these 4 questions after every assessment that you have in any other class as well. You write a paper, ask these 4 questions. How are you going to better that next paper? Do a project, same thing. How are you going to better that next project? Do a lab, how are you going to better that next lab? Okay? So again, this is something that I want you to, it's a promise that you're keeping for yourself or to yourself, so that before exam 2, you're going to change your question 1 and 2, or your answers to question 1 and 2, so that, now some of you guys don't need to change anything, right? Exactly what you're doing is exactly what you should keep on doing. The only question is there a more efficient way? Okay? Now, guys, there's no shame for the ones that did not get the grade that they wanted to ask the students that got the hundreds, the 96, 92, 88s, how did they study? Right? There's no shame in that whatsoever. Right? That's how people got better at things, is because they were willing to ask those questions. How did you do it? Are you willing to mentor me through it? Right? It's asking for those helps. So there's no shame in that whatsoever. So with that being said, is there any questions for me? About anything. Did it look like the review? Okay.
Props to you for letting us keep them to be able to study for our final capacity.
There's a lot of things I do that they don't do. You know what the problem is going to be? Is that you're going to leave me and you're going to be so spoiled that you get to the next class and next professor, you're like, crap, where's my review? Where's my study guide? Where's my pre-recorded notes?
No, we know. You do it so we can do it for them. And then we can say you need to go take a mentor class.
Which hand? There's no shame in asking. The problem is they don't want to put the work in. So, because they think that I was born and it was like, oh, there it is. Everything's right there. It's the same as anything that we do, right? What we're good at is because we actually put the time in. But so any other questions for me? Nothing? Are we now willing to ask the questions that needs to be asked when it comes to notes? Because I think there's some of us that might not understand something and not willing to ask the questions that needs to be asked. Because I'm so mean.
I liked how we did the review though, where we went out.
tutor that you liked at the beginning of the semester?
Yes.
Where is this information? Is this information in the syllabus?
It is not information in the syllabus. It is information, I think, on the second day of class. So if you want to go back to that live lecture, his name is Daniel Reynolds. I can't remember the hours that he's working, though. I think it is in the library. He is in the library. I think it was Tuesday, Wednesday, Thursday. If you do it via Zoom, there's someone else I'm also liking, but I don't know how often he's on. I can't remember his name now. He used to be here. If I can remember, I'll tell you. I'll say it. Shoot, what's his name? I can't remember. No. He was here as a math tutor, and now he's up at Port Charlotte, I think. Luis Hernandez. So that would be a person, if you're on Zoom, that would be a person to ask for. Any other questions? Yeah?
Why do you assign the lab work due first and then the MLM?
The question was, why do I assign the lab work to be due first before the MLM? Okay, so the reason why I have the lab work due earlier is because I'm trying to force your hand to open it earlier so that you'll be willing to ask questions during class. Does that make sense? Yeah. MLM, I know that you guys can figure out. Yeah. But the lab work, I know there's questions. And if I had it due on, let's say if I had it due on Saturday, the problem is that nobody will open up until Friday after class is done. And then I'll get a bunch of emails saying, how do I do this? So I'm just trying to force your hand to open it early. But speaking of lab work 4A, anybody hand one in? I gave 100%, but I also still made comments. So when I was grading them, I still saw question number 1. Is that true? If I'm correct, question number 1 was very similar to this question, wasn't it? It was system of nonlinear equation, wasn't it? Yeah? What was the biggest mistake? So this was lab work 3, number 9. And when we talked through this, right? In fact, what was the biggest mistake that people made? Because not many people got 100%. Actually, I think only 1 or 2 people got 100% of this. When you found the 0 and -5, most people did not plug the 0 into both equations and the -5 into both equations, right? That's number 1. Number 2, is the what we know already done for you right here? So in other words, I gave you the answer, and you just decided to flip me off and not write it on lab work 4A. It's right here. You had a copy of it. You could have just copied it. But you decided, nah, I'll use my own words. And then go, I'm confused on what you want me to write. I already gave it to you. You still didn't write it. Does that make sense? So if you're wondering what to write and you're wondering if I should give you what to write, you're telling me it doesn't matter what I give you to write. You're not going to write it anyways. Right? Because I gave you this. Now, I don't remember if the problem was asking for specifically elimination or substitution, or was it the same thing as this where it said method of your choice. If it says method of your choice, you got to talk about both. If it just says elimination, just talk about elimination. If it talks about substitution, just talk about substitution, right? But if it says method of your choice, then you got to talk about both. So you do not need to show both methods. In the what we know, you got to talk about both methods. And then you can choose to whichever method you want, just like the direction says. Okay? I only show both only because in case if some of you guys did elimination, some of you guys did substitution, great. All right? Any other questions? But essentially, no matter which way I did, I got to the same equation anyway. So we good? No questions. Well, remember that every single lab work is set up that way. So let me go here. So if you look here, I give you guys 2 templates. You don't have to print these out. But the right third of the paper should be the what we know. Now, the what we know is, someone put it beautifully, as a guide. So none of the stuff from the prom should be in the what we know. So what we know should be like a direction, a guide of how to do that type of problem. A dictionary? Yeah, like a reference guide. Like a reference guide. We'll call it a dictionary.
Dictionary's got a run.
How about like a instruction manual, per se? Fair enough? Yeah. Okay. So that's what every single lab work should be like, right? Now, if you guys still have issues with scanning, I don't have a problem with you guys asking the question, right? Again, you don't have to print these out, so on your notebook, you can just draw a straight line on the far right side and just put down what we know. Now, every what we know should correspond with the problem. So if what we know gets to down here and problem number 1 only gets to here, then start number 2 right here, okay? Any other questions? Nothing? So we're ready to start notes. We're ready to rock and roll. All right. Then let's start talking about functions and their graphs. Yes, sir. You may. I'm just saying that. I just keep on talking. He's like, is there, okay, great. Does anybody else want to lend me a pen?
What numbers is this?
I don't talk about numbers anymore.
Just so you know. Are we doing 2.2? Oh, that lecture video is long.
That's why today I'm only going to do part of it. I'm going to finish this and then part of. But so the reason why I'm not using numbers anymore is because I'm kind of trying to intertwine all of them together. So you're getting bits and pieces right now individually, and I'm going to kind of do that. All right. So when we talked about functions and their graphs, one of the things that we always talk about is domain and range, right? And what the heck is a domain? Can anybody give me a definition of domain? All possible x values. And range? Awesome. All possible y values. And what do we usually get asked with domain and range? If it's a function or not, right? If it's a function or not. Okay. And it's funny because all these years of teaching, I don't think I ever given a definition of what a function is. You're not even in a video. I never given what the actual definition of a function is. Did I? So a function is where each x value corresponds with one and only one y value. Was that close? Okay. So that's what a function means, right? So when we did these things, we were given a couple of ways. One was if we were given points. You guys remember that? We were given points. And we say, what's the domain? What's the range? Is it a function? Or we're given a graph. What's the domain? What's the range? Is it a function or not? Well, this semester, we're now going to be given an equation and saying, what's the domain? We don't really care about the range. And is it a function or not? So now we're adding on to it an equation. Okay? So let's do a quick review. If I'm given points, how do I figure out if it's a function or not? If what? Awesome. Awesome. So given points, if x repeats, not a function. Now, in intermediate algebra, I talked about food poisoning and functions, right? So I ate Ruby Tuesdays, one input, and I had two outputs. Meaning I got sick, and I had number 3. The reason why I call it number 3 is because there's a consistency of number 1 coming out of your number 2, a number 3. It's like flushing stuff out of your body, okay? So, again, x, y. Same x, different y. Hence the x repeated. Hence my body was not functioning. Make sense? Right? That's why, that was the way for me to remind my students that when x repeats, it's not a function. Okay? How about if we're given a graph? How do I know if that's not a function? Ooh! And here's the thing, guys. If you think about x repeating, right? If you wrote 2 points where the x repeated, and you were to graph those 2 points, wouldn't those 2 points make a vertical line? That's where the vertical line test came from. So vertical line test, the VLT. So if a vertical line crosses a graph more than once, not a function. So what if we're given an equation? How the heck are we going to figure that out? So let's say given so let's take an example. So how are we going to figure out if this equation is a function or not? So let me ask you guys this. What kind of graph is this? If we were to graph it, what kind of graph is this? We talked about this. I'm going to do a reminder right now, right? Here we go. Ready? So one of the things we learned was a line, right? A line has what variables in it? X and y both to the first degree, yes? Which gives me a diagonal line. A diagonal line has an x to the first degree and a y to the first degree. It's because it's going to, most of them are going to cross the x-axis once, first degree, and the y-axis once, first degree. Right? A vertical line crosses the x-axis once. Hence, this equation is going to have an x to the first degree and no y value because it doesn't cross the y-axis. A horizontal line is going to cross the y-axis once, first degree, but doesn't cross the x-axis. Hence, there's no x in the equation. A parabola, most of them is going to cross the x-axis how many times? Twice. That's why it's x squared. The y-axis how many times? Once. That's why it's to the first degree. So if x is to the second power, y is to the first power, we got a parabola facing up or facing down. So if the y is squared and x to the first power, what kind of parabola do we have? A sideways. We're not sure which way, but sideways. Because it's going to cross the y-axis twice and the x-axis once. Holy cow. So what kind of graph do we have here? So is it a function? Right? Okay. But if you were on the lab where you read the graph and say, it didn't know a function fails the numerical line test, I'm going to say plus 0. Let's move on, right? Because I want you to prove it using the equations. So how do I prove an equation is not a function? Right? Solve for y. Right? Get y by itself. If I was to get y by itself, you're going to get what? Y is equal to Is that right? What's missing? Yeah. Every time we take the square root, we got to include the plus and minus. Yes.
I was watching the lecture last night for this one.
Mm-hmm.
I was a little confused on
Not that guy again.
I was confused on whether you can further solve it or you just.
You actually cannot further solve it. The only way to further solve this is if this was factorable to, let's say, like x plus 4 squared. Then it can reduce more. But if not, it cannot.
So would you keep the x in the square root and then put the, let's say it's a 9, 3 on the outside?
Nope. Nothing to do right now. We're just right here. So we got to look at this equation and say, is this a function or not? Okay. So here's the thing. Again, first of all, speaking of domains, what is the domain of this function right now? Can I use 3 for my x value? Why not? It's going to give me a square root of negative, which gives me what? It gives you u. Awesome. It gives us a bunch of imaginary numbers, right? Imaginary was cute when you were 3 years old, when you had your imaginary friend. But now if you walk around with your imaginary friend, you're going to be given a lot of drugs and a straitjacket. Yes? Okay? So let's not include those imaginary ones in there. Okay? Let's keep those out. All right? So what value of x's could I put in there? Can I do 7? 17. I can do 17. What else can I put in there? Yep. What is the smallest number I can put in there? Can I put 1?
No, you cannot.
No, you cannot, because 1 minus 8 gives me negative 7, right? Can I do 8? Can you do this? Can you take the square root of 0? Try on your calculator. You can, right? It's 0. So you can do 0. So you can do 8. What else can you do? So you can do 8 or anything above 8. So square bracket 8 to infinity, parentheses. There's my domain. Does that make sense? Okay. What's the matter? Okay, so can I use 9? Can I use 10? Can I use 2,000? Can I use 3,000? Can I use 1,000,000? So my number is getting bigger and bigger towards positive infinity. But it started at 8. Square bracket 8, comma, infinity, parentheses, because I'm never going to touch infinity, right? Make sense? We're good? Okay. So, okay, let's pick another x value. So we picked 17. If we use 17, what's 17 minus 8? What's square root of 9? So if I use 17, how many y values do I get? Do I get 2? Because I have positive and I have a negative. So because of the plus and minus, it's always going to give me 2 y values. So therefore, each x value is going to give me 2 y values, therefore it's not a function. Because each x value can only give me one and only one y value in order for it to be a function. But since it gives me 2, it's not a function. Make sense? Well, on the lab work, you're going to have to explain that a little bit more. Why does a plus and minus make it not a function? Does that make sense? But yeah, I agree with you. When you see this, you can say, but like I said, you got to further explain saying, hey, since the plus and minus will give me, for each x value, will give me 2 y values, the positive and the negative, that's why it's not going to be a function. Make sense? Are we okay there? So, again, given points, x repeats, not a function. Given a graph, the vertical line crosses the graph more than once, not a function. Equation, get y by itself. If there's a plus and minus, not a function. Anything else that doesn't involve y squared, essentially, right? If this was y to the third, it's a function. No, x squared is okay because you're getting y by itself. If it was x squared and the y is squared, then it's not a function. Because here's the thing. If x is squared, y is squared, and it's adding the x squared, y squared, it's going to be a circle, so therefore it's not a function. Or if I have a hyperbola, I don't know how to do that. Either this or this, right? Not a function again, right? Because it's going to cross. Make sense? So essentially, anytime the y is squared is not a function. All right? How do we do over there? Now, here's my next question. So, did anybody have a problem with number 10 on log work 4a? It was finding the domain and range of that rational function. Okay. So let's do that really quick. Remember this problem right here? Okay. Did we have a problem with finding the domain and range here? Now, mind you guys, domain and range is domain and range. No matter what the graph looks like, the domain and range is still the same. Okay? Because the domain was what was the definition of domain again? All possible x values, right? So x value goes which direction? Left and right. So let's say, for example, that this right here is my graph. Kind of looks like this a little bit. Kind of, right? All right, so let's say this is our graph. If I was wanting this graph to only point left and right, would you agree with me if I put a spotlight right up here and cast a shadow down, the shadow on the floor will look something like this in your eye, right? Just this edge and this edge, okay, on the floor, right? Arrows here and arrow here, but it's just going to point like this. So on this graph, it's going to look something like this. And like this. Okay? So that's what it's going to look like, right? It's going to look something like this. But you see this little hole in the middle. Yes? So we see this little hole in the middle. Okay, not that. Okay. So if there's that little hole, then to the left is going to be negative infinity. To the right is positive infinity. And this hole is at 3. So therefore, my domain is going to be that. Because again, I only want to see x left and right. So that's why I cast a shadow. Okay? Now, if I'm looking at the range, and the range is all possible y values. Y value goes up and down. So if I was to cast a shadow for this, I will put a spotlight right here and cast it to the wall. Right? So essentially, you're going to see something like this. Does that make sense? Because if I look over here, that's all I'm going to see. Essentially, you're seeing this. No matter how I put it, it's just that, right? So you're going to see something like that. And now this graph doesn't do a good job, but this graph doesn't do a good job, but essentially this is going closer and closer to 0, but never touching it. Okay? So it's going to be something like that. So this is at 0, this is at infinity, so my range. I just heard someone in the beginning of class that says the graph on MLM suck. Okay.
You know how you have a little slider thing? You can slide that down and then magnetize it so the graph doesn't get cut off by that line.
Gotcha. So that would be my range. Does that make sense? So if I can cast shadows, it'd be worthwhile casting shadows. Okay? The other way I talk about it is, like, if this was my graph and I only want it left and right, I would take, a pile of paper and just slam it down so it just squishes down. If it flattens out, all I see is this as well. Right? Same thing if I go from left to right and I just want to smash it together, right? Just smash it. On the wall would just be just that piece left. Okay? So that's how I look at domain and range. Is this a function? Yes? Because it does pass the vertical line test? All right. Any questions there? Nothing? Nothing? Okay. So we talked a little bit about this domain. We said it's going to go from 8 to infinity. Why? What is it about this equation that makes it so it's limited from 8 to infinity? What makes this so that it becomes imaginary? So therefore, that's no good, because I don't want to be in a straitjacket and fed a bunch of drugs. I said, what is so special about this equation that makes it where I have, let's call it restrictions, of numbers that we can use because it causes imaginary stuff happening, right? So what is it about this equation that makes this happen? Not intercept, but why can't I use 7? No, not because it goes in, well, it is because it goes in negative, because square root of negative is imaginary. I just said the word. No, square root. It's a square root that makes it, that perks up our ears about what to look for. Because if the square root wasn't there, we don't give a turd about what numbers to use, right? If we take away that square root, do we care what number x is? Is there anything that holds us back? No. Once that square root happened, it was like, ooh, wait a minute, I see a square root. And then when we're like, we can use 7. Ooh, wait a minute, we can't use 7. Right? It's because of that square root that perked us up going, we got to be careful here. Does that make sense? So, with domain, guys, we are always, this is going to be, this. I hate this. We are always going to assume that the domain is going to go from negative infinity to positive infinity, aka all reals. So if you see infinity, negative infinity to positive infinity, it means all reals. Unless we see a square root right? Because when we saw a square root, what were we really looking for? What would make we don't want imaginary numbers. So we wanted to keep the radicand, greater than or equal to 0. Is that true? Is the question, what the heck is a radicand? So we all know what the radicand is. Ooh. Yes, the radicand is the number inside the square root. So in this example, the radicand is the x minus 8. So we want to make sure that x minus 8 is going to be greater than or equal to 0. Okay? Do you guys have any idea what's the second thing that we have to keep an eye on that should perk our ears up and tread lightly? Because if we tread wrong, it becomes undefined. That would be a little clue. What is it? Same letter, same ending, wrong center. She says function, so was right. Shen is right. Just the middle is wrong. Fractions. Because if we don't tread correctly, we become undefined. Why is it undefined? When is a fraction undefined? The other way. 0 in the denominator. Does that make sense? Right? When there's a, so if you took 8, if you took your calculator and did 8 divided by 0, the calculator is just going to flip you off, right? That would be awesome if it did. Right? What? No. You cannot divide by 0 because anything divided by 0 is undefined. So that means it never existed. 0 divided by 8 is 0. So fractions. And what we know there is that the denominator cannot equal to 0. So those are two things that we're going to look at. And what we got to be careful with, however, is the third possibility is if these two are combined. If we have a square root in the denominator of a fraction. And then the fourth is going to be during our fourth exam. So that's a couple exams away that we're going to learn about the fourth thing. But the third thing would be that. So So we had this. We would just say that x minus 8 has to be greater than or equal to 0 because it's the radicand, right? There's a good example of number 1 here. Okay? So now we can say, okay, x has to be greater than or equal to 8. So that's why we have 8 comma infinity. Does that make sense? We're okay? Questions?
Why do we do square bracket?
Because of the equals to. That means we can include 8. Because 8 is included in here, right? We can use 8 because we can take the square root of 0. So we include the 8. Okay? But what if, and I'll put this as number 3 because now you're going to be confused. You're going, where did that come from? So can I do this right here for this one too? What can't happen? Huh? That's a whole different story, but how do I find the domain? Okay, Again, if I have this right here, and I have this right here, they're the same, right? So I can say that this is greater than or equal to 0. Can I say this is greater than or equal to 0? What can I not say about this? So I can't say equal to 0. Because if the denominator was equal to 0, what happens? Fraction's undefined. That means the fraction never existed. So I can't have the equals there. Huh? Well, I'm trying to find the domain, right? So
then that creates.
because it's a denominator in the fraction, that means the denominator cannot equal to 0. So that means this cannot equal to 0. However, because it's a radical, I know the radicand has to be greater than or equal to 0. Radicand has to be greater than or equal to 0, but it cannot equal to 0. So that's why we got to take the equals to away. Does that make sense? Now we can solve this, and what does that give me? See, just because of the denominator, look, I got to take 8 away. Are we okay? So we okay? We good? All right. Are we sure? Really sure? All right. Then let's start talking about function notation. So if I was to ask you guys to do something in function notation, what does that mean? Right? Is where we replace the y with f of x. You guys remember that? So let's take the function f of x is equal to x squared plus 6x plus 2. Okay? If I was given that function, and I asked you to find f of negative 2, what would that be? So you're saying if I was to compare these two right here, I see that where the x was is where the negative 2 is. So which means that in the equation, wherever x is, I'm just going to replace it with negative 2. Awesome. So f of negative 2 is just going to equal to what? Or negative 6? Yes, it's 4 minus 12 plus 2, yes. And I love what you just said. What did you say again? Say that again. We plugged in an x of negative 2 and got a y of negative 6. This is said before I even asked the question. Awesome. So you're telling me that what I'm solving for is actually a point on the graph. Right? So this gives me a point. Or better yet, if I was to translate this right here, it is right? When x is equal to negative 2, y is equal to negative 6. Great. Okay. Now, I'm going to come back to this. I want to come back to this because on the graphing, this is going to matter. Okay? But before I do that, I'm going to ask you guys to find, with the same f of x, so same f of x, guys, I want you to find me f of x plus h. Tell me what that equals to when I return from my short commercial break. Or little boy's room break, one or the other. How did we do? Wow, that good, huh? That silence. We did that good. Did we get x squared plus 2xy, xh plus h squared plus 6x plus 6h? x squared plus 2xh. Well, because you have xh and hx, right? No. Well, no. Well, okay, so putting this in order is a little complicated, but let me do this. Here. Let me just write the whole thing out. I don't really care about the order, guys. But those are all the terms that you needed. No. Because the purpose of this whole thing, the order won't matter. Because at some point, the f of x is going to actually cancel out, but we'll talk about that in just a bit. But do we have all the terms? Correct terms. Okay. So no question, we're good. Absolutely nothing yet.
It's a long equation, x plus h equals y.
Very true. Very true. Okay, so let's say I give you a graph. And I call this graph f of x. Okay? I don't give you an equation, but I just give you the graph. And I say to you, hey, this is f of x, so I need you to find me f of 0. Someone said 2. Someone said, I don't know. Okay, so let me remind you guys of something, and I'll come back to this. Remember we just talked about this right here? F of negative 2 equals negative 6 means it's a point negative 2 comma negative 6. Is that correct? And if we were to translate this to English, it says when x is equal to negative 2, y equals negative 6. Is that correct? Okay, great. So if we go back to this graph right here, if I say f of 0, that means the x value is what value? 0. What am I looking for? The y value. Okay, go look at the graph, find out where x is equal to 0, and tell me where the y value is. Does that make sense? Because where is x equals 0? Isn't that x equals 0? Where does it cross the graph? At the y value of 2. Okay. Let's take a second chance. F of negative 2. Does everybody see negative 6? Negative 2. Okay. F of negative 3. Will be negative 6, right? Are we okay here? Not bad? So in other words, that's the reason why I was saying, hey, if we know what that means, that is x comma y is actually a point, then we can find those points on the graph, right? Where is when x is equal to 0? When is the x equals negative 2? When is the x equal to negative 3, and so on? Then we can find the y value. No big deal, right? Okay. So let me ask you guys this. If you had to guess x and y wise, what degree is the x in this equation? It's squared because it crosses the x-axis twice. And the y is to the first degree, right? Because it crosses the y-axis once. Okay. How would I go about finding the y-intercept? Ooh. So the y-intercept, you're telling me that x equals 0. If you guys don't know this, plot a few x-intercepts and name them. And you're going to realize that you're going to keep on saying 0, comma, blank, 0, blank, 0, blank, where the x value keeps on coming out to be 0. So with that being said, how about x-intercept? Is where y equals 0. Right? So again, for the ones that had me before, I told them that these two things we need to remember for the rest of your math career. It's going to keep on popping back up.
For what we know, we could state that.
Yes. Yes. If it talks about x-intercept and y-intercept, yes, you definitely want to. Okay? Now, what is cool about parabolas? What's so cool about parabolas? What's so cool about parabolas? So, let me ask you guys this. When I show a parabola, I always do this, right? Do I ever show your parabola like this? Why won't I show it like this or like this? Because it's what? It's symmetrical, isn't it? Isn't it always symmetrical? Meaning, I can put a line right down the center. Right? I can always put a line right down the center. Meaning, if I plot this point right here, I know exactly where to plot that point right there. True? If I find a y-intercept, I know exactly where to plot that point right there. Is that true? So those are all symmetrical. Okay? That's so cool. That's what's cool about parabola. Now, with that being said, we have something called an even function. However, even function isn't all parabolas. Okay? It takes a special parabola for it to be an even function. So an even function is when we have symmetry about the y-axis. Okay? It has to have symmetry about the y-axis. Now, do you think that a lot of graphs is going to have symmetry about the y-axis? The answer is going to be no, because think about this. If I have a parabola right here, how many parabolas, let's say that right now I'm symmetrical by the y-axis. How many of these parabolas are going to be slightly this way or slightly this way? Isn't there going to be a lot more of those than the one that's perfectly in the center? Right? So is there going to be a lot of even ones? No. There's going to be way more that are not even than even. Okay? But we still need to know if they're even or not. Okay? So there's, so go ahead.
So does this start with, like, an even function is always 0, 0?
Not always 0, 0, because I could do this, right? That's still even. Does that make sense? Okay, so let me ask you guys this. If I plot these 2 points right here, and you were to name them, would it be this and this? Is that correct? So the y value is exactly the same, but the x value, the signs flip. Right? But symmetry about the y-axis makes sense. Right? It's just a reflection. So the question is, how do I write this in function notation? We've been talking about function notation. How the heck am I going to write that relationship in function notation? Because if you look at this, it's going to be this, right? Negative x comma y, and this is going to be x comma y, right? Meaning the y stays the same, but the x flips signs. So in function notation, we'll write this. So notice that they both stay the same sign, both positive, while the x flips signs. Everybody see that? So y stays the same, but the x flips signs. And if we have even functions, we must also have a odd function. Give me a second here. So this would be an odd function. So this has symmetry about the you're right though, it is. And that is called the symmetry about the origin. Where you have a symmetry about the x and the y-axis, it's actually called the origin. Meaning the mirror is the origin. So if you look into the origin, your reflection is on the other side. Okay? So that's why if you're here, you look through, it's going to be here. Right? Unlike this where you look here, it's going to be over here. Okay? All right. Do you guys agree with the points? So if I was to write an xy value, it would be x comma y, and this would be negative x comma negative y. Is that right? So that means the y negates and the x negates. So how do I write that in function notation? Agreed? The x negated, so does the y also negates. Okay? Are we okay so far? By the way, guys, just so you guys know, I've been asked to do a trial of something called a Boodle box. And I'm thinking about using this class as that trial.
I have a question for you. So why is it not f of x? Why is there a negative in front of the x?
Because
When it's 2,
because the x flip signs and the y flip signs. Right? Yeah. Right? Because then the x flip sign and the y flip signs. So this f of x is positive, while this f of x is negative. So in other words, the y flips signs. This x is negative. This x is positive. Oops. This x is negative. This x is positive. So again, they flip signs. Same thing with the y. Right? So Boodlebox is essentially what happens that you guys will all have a membership on Boodlebox, and Boodlebox is basically putting all the different AI stuff together as one. So in other words, you would be able to use ChatGPT at its fullest, and then you can tell Claude to check the answer of chat to confirm that it makes sense or is it wrong, and then you can pull up Gemini and say, are they right? Right? So and then there's different bots in there that you guys can use to help with different things as well. So I'm thinking about asking you guys to be that trial.
Boodlebox?
voodoo box. But I just bring it up right now, and then when I get more information, because I found that the math, looking at the math stuff, it looks kind of weird. So I'm trying to not do it based on math stuff. Maybe I can do it based on the what we know stuff. So we'll look at that. Okay, so let's only focus on just these two things right here. Okay? What looks the same? The equal sign. Awesome. Do these two look the same? Exactly the same, aren't they? Yes? Exactly the same. So the only difference between even and odd, right? Because remember, this was even. This was odd, right? So in other words, if we can find this and compare it, we can know what's even, what's odd. Does that make sense? So we find this, and it looks like the red, it must be even. If we look at, find this, it looks like blue, it must be odd. Is that fair? Okay. So now I'm going to follow this right here. Okay? So let's say I'm given a function. Okay? So what they're going to ask is this function even, odd, or neither? So there's actually three choices. So if it's not even, it doesn't mean it's odd. If it's not odd, it doesn't mean it's even. Understand? Because there is a neither. There's a third choice there. Okay? So if I look at this, and I look up here, right? Up here, there's really only three things. 1, 2, and 3. Is that true? Does this look like any of those three things? Which one? So, do you agree that this is my f of x? It says f of x. Agreed? Okay? That says f of x. This says f of x. Awesome. So if it looks like this, it must be even. What is it going to look like if it was odd? So it will have to look like that. Can we find this? Because isn't this just saying negate f of x? So in other words, I can just go negate. That's all it is. It's literally just flipping the signs. Does everybody agree? That's pretty easy. It's just flipping the signs. I'm just taking the f of x and flipping the signs. That's it. We're okay with that. So again, f of x is given. First thing we're going to do is find what's the opposite of that, right? Negate everything. Then there's only one thing left. Yes? Now I need to find f of negative x, right? So this way I can compare, does it look like this or does it look like this? Does that make sense? If it looks like this, it must be even. It looks like this, it must be odd, right? So we got to figure out what this is. How do we find this? Plug it in, plug it in. X4.
F of x.
Right? And what do we get? Does that look like even, or does that look odd? Doesn't it look odd? This is actually odd. Right? This looks exactly like this, so it's odd. This definitely does not look like this. That's why it's not even.